All right, rock and roll. So let's organize this a little bit and then kind of look at what the problems are going to look like. Okay, so here's the thing we need to remember. Okay, learning target 1 is about that uniform density curve. Okay, and the thing that's important to remember about that is if we set it up, it's going to look like a rectangle, right? So it's going to go up and over, okay? And we're going to leave this in kind of generic terms. So we're going to say it goes over a distance of k, all right? So the bottom side would be a distance of k. The top side would be a distance of 1 over k. So whatever number is out there, the height is always going to be 1 over, okay? To get our total area, we do 1 over k times k, which is just 1, okay? So it's length times width, right? So our area is length times width. So not always will we do the entire distribution. We may take a small portion, find that length, and then multiply by the height, okay? So we'll do one like that. Okay. Learning target 2 was all about the mean and the median with the different types of curves that we have, okay? So with a symmetric curve, right, so that looks like that. The mean and the median are equal. Okay, so mean equals median. Okay, so that's important to remember if we have symmetric. Okay, our mean and our median are going to be equal. If we're skewed, right, so we can go 2 ways. We can be skewed right or we can be skewed left. So skewed right would look like that. Skewed left would look like that. Okay. The median's always going to fall at that tallest part of the curve. And the mean's going to fall a little bit away from it. Okay. So in the first one, median is less than the mean. And the other one, median is greater than the mean. Okay, so just knowing those locations. I think there's one here in a second that we're going to do where it just shows you a curve. We have to pick which one we think is the mean, which one we think is the median. Okay. Yep. Okay, so then finally, the last thing we want to talk about is that normal distribution, right? And this entire chapter from here on out is about the normal distribution, okay? So we'll spend a lot of days working with it. Okay. So the normal distribution is that symmetric curve. It'll have a single peak, usually right there in the middle. All right, and it's kind of bell-shaped. All right. I'm going to teach you some new variables today that we use in statistics. Okay. With a symmetric curve, the mean and the median are in the same place. They're going to be equal right there in the middle. We did that a few minutes ago. Okay. But we talk about the mean, and we use this new symbol, okay? it kind of looks like a fancy M, all right? So a U with a tail or a fancy M. That's a Greek letter known as mu. What does a cow say? Mu. No, it's a bad joke. Anyway, okay? But we call it mu. That represents the mean. Okay, so the mean will always be in the middle. Then one of the things that we do is we go forward 3 standard deviations, and we go backwards 3 standard deviations from the mean. Okay? Now, the symbol that we use for a standard deviation, all right, so standard deviation, it's kind of like a sideways 9, all right, a circle with a hat, all right? That is the lowercase Greek letter sigma. Okay, so it's kind of a sideways 9. That's the easiest way to draw it. But that is the symbol that represents standard deviation. Okay, now, I don't know why the people who decided all things statistics wanted to use Greek letters, but they did. Okay, so that's what you're going to see, all right, in your applet, right? So what I want to do is just to walk you through what some of these problems look like. Okay, of all the things we've done so far, this lesson's probably one of the easier because we just add and subtract. All right, we do a little bit of multiplication, and that's about it. Okay, so it's not a ton of stuff that we have to do. Okay, so what we'll be asked to do tonight is talk about from Learning Target 1, how to get that area. All right, from Learning Target 2, where's the mean or the median, all right, in the curve, and then finally how to set up that normal distribution so that it's symmetric. All right, so that's what they're going to ask us to do. All right, so let's take a second and let's look at this very first example right there. It says draw a density curve to model the amount of time after an hour at which a request is received by the web server. Be sure to include scales on both axes. Now, this tells me a lot up here in the paragraph, but it says for one particular web server, the time in seconds after the start of an hour at which a randomly selected request is received can be modeled by a uniform distribution. If you see that word, you're going to think rectangle. Okay, so if you see the word uniform distribution, you're going to think I'm making a rectangle. All right, on the interval from 0 to 3,600 seconds. Okay, so from 0 to 3,600. That's important because this is going to tell me how to set up my rectangle. So here's what we're going to do. We're going to draw our axes. On the bottom is what the interval's from. It's from 0 to 3,600 seconds. I cannot spell. Okay, so that's where that interval comes in. Now, this is where I have to know the statistics part. Okay, we know it's going to be a rectangle, so I'm just going to draw it. But the thing I have to label is my height. Okay, how tall is it? Well, that comes from that number on the bottom. Okay, 1 over 3,600, and that's it. That's all it wanted me to do, was just to draw the rectangle with the right value on the bottom and the correct value on the top. All right, for the height. That's all it's looking for. That's not too terrible, right? Okay. Okay. So now let's look at some other questions they're going to ask me about this rectangle. What can I do with it? So it says on number 2, about what proportion of requests are received within the first 5 minutes. They tell me that's 300 seconds after the hour. All right. So here's what they've done. They said, you know what? I don't need the area of the whole thing. I just need an area of a part of it. Okay. What time do they want me to go to on the bottom? 5 minutes, which was how many seconds? 300. Okay. Does the height of my rectangle change? No. Okay. So we're going to take the bottom, 300, times 1 over 3,600. We're just going to use our calculator and multiply. okay? It's going to give me a decimal. We're going to leave it as that decimal. That's all we're going to do, okay? So if I pick up my calculator and I type in 300 times 1 divided by 3,600, gives me 0.083, and that's my answer. Okay, so that's all we're doing is multiplying. I'm taking a smaller portion of the whole rectangle. It is length times width. All right, base times height, however you want to think about that. All right, with a rectangle. All right, so then the next thing it asks me is to find the interquartile range. Now, this is a little bit weird, okay? Because, first of all, I don't see any quartiles up there, all right? Nobody told me any of that, okay? So let's think about that. How do I get an interquartile range? How do we do that? What does it take to do it? Q1 and Q3, and we're going to subtract them, right? That's how we get an interquartile range. Well, I got to figure out where is that third quartile and where is that first quartile. So let's talk about it. A quartile divides my data up into how many sections? 4. Quartile meaning 4. It divides it into 4 sections. And so if I think about quartile 3, that would be 75% of my data. Okay? So quartile 3 is always going to be 0.75. And then how long is it? 3,600. Okay? So I don't want the full height. I just want 75% of it. Quartile 1 would be how much of the data? 25% or 1/4. So 0.25 times 3,600. So we got to find those two numbers. Okay? So we just have to think that the quartiles fall. 3 is at 75%. 1 is at 25%. All right? So let's get those numbers, and then we're going to subtract them. All right? So for quartile 3, we would get 2,700. And then for quartile 1, we would get 900. And then for my interquartile range, 2,700 minus 900. Should be 1,800 seconds. Okay, so we had to do a little extra math right there. We had to remember what a quartile was and what percentage did it represent. Okay. Question about that. I think that's the toughest question they're going to ask me to do. All right, so we just have to remember that quartile 3 is at 75% of the bottom and quartile 3 is at 25%. Okay, now what's the mean of this density curve? Well, because it's a rectangle, where's the mean going to be? In the middle. All right. So if the whole thing's 3,600, where's the middle? Half of it, right? I can take 3,600 and divide it by 2, and I get 1,800 seconds. Okay. Well, if that's the case, what's the median? 1,800 because they're equal. All right, 1,800 because mean and median are equal in a uniform distribution. Okay, so that's all about the uniform one. All right, I want to do 2 more examples, or maybe 3 more examples with you, just because they're worded a little differently, and I'll be sure we understand the math we need to do that. So go over to your other examples, and let's look at those really quick. All right. So on this one, again, it's still talking about something that's uniform. How do I know that? Well, if I read through there, it says the random number generator will spread its output uniformly. That's the key word there, that it's going to be a rectangle. Across the interval from 0 to 4 as we allow it. Okay, so the first thing it wants me to do is to draw that rectangle. All right, what numbers are going on the bottom? 0 and 4. We're going to draw in our rectangle. What's the height going to be? 1/4. Okay, that's all it wants on that first part, is draw that rectangle. Okay. Okay, that's all it needs. Now, the next one is where it gets interesting, because it says about what percent of the randomly generated numbers will fall between 0.87 and 2.55. So I don't want this entire rectangle. I only want part of it. Okay, so 0 to 4. I only want the part that goes from 0.87 to 2.55. Okay, the height of my rectangle didn't change. All right, it's still up here at 1/4. Okay, but what did change? Yeah, the length of the bottom. Okay, and so if I want to find that percent, here's what we're going to have to do. First, I got to figure out the length of this bottom. So let's take 2.55 and subtract 0.87. Okay, that's going to be my base of my rectangle. All right. Somebody got that? 1.68. Okay, so that's my base. All right, my height is still what? 1/4. And so to get my area, which is what I'm looking for, I'm going to do 1.68 times 1/4. Right? Now, it's going to give me a decimal when I do that. Right? It's going to give me, I think, 0.42. Right? That is not a percent. It's a decimal. So how do I make it a percent? Times 100. Okay, so the only time you multiply by 100 is if it asks you for a percent. Okay, so you may not do the whole rectangle, you may just do part of it. Find the length of that base. Okay, find the length of that base, then multiply it by the height. Base times height every time. Okay, when it's uniform, which is nice. They said allergies are super high right now. The weather last night, the grass, the tree pollen, all the good stuff. But it's going to be like the high this weekend, y'all. It's going to be like 70. Lows in the 50s. Oh, it's going to feel like fall. I'm going to need a s'more. Anybody got a fire pit? I wish I had one. I'll come visit. Okay. Okay, I'm coming to Eli's house. I'll bring the marshmallows. Okay. Do y'all really? Y'all know Brooklyn's my next door neighbor. Did y'all know that? Anyway, she's my next door neighbor. My dogs love her dogs. They don't like anybody else, but they like her dogs. Okay. All right, let's look at this one. All right. So we're still talking about that same rectangle, okay? So we still went from 0 to 4 and up here at 1/4, okay? But it says to find the 65th percentile of this distribution. Y'all, what that means is it wants to know where's 65% of this data, okay? Where do I go to get 65%? All right, so we're trying to find this number on the bottom that's going to give me 65%. So let's think for just a little bit. That's something I don't know, right? I don't know the bottom. I do know the top, though. I know that 1/4, all right, and let's just call that X, all right, 1/4 times the bottom equals, what would 65% be as a decimal? 0.65. We know it always gives me a decimal. Okay, so we're going to have to solve an equation, rut row. How do I undo multiplying by a fourth? There's a couple of ways. Yeah, you can multiply by 4.
Or convert it.
Yep, or make it 0.25 and divide by 0.25, right? So you could have said that's the same thing as 0.25x equals 0.65 and just divide by 0.25. Whichever way you want to do it is the same. Okay, now if we do that, my missing number that I was talking about is 2.60. So there may be one where it asks you to find a percentile. Okay, And that just means you're going to have to solve an equation because we don't know how long the bottom is. We know the area is 0.65, but I don't know what the base was. Okay, we'll always know the height, which is nice. Okay, so we'll always know the height, but not necessarily the bottom. Okay. I can't remember if there's one like that on this assignment, but just wanted to show it to you. Okay. All right, on this one, just look down at the bottom. Okay, so just this one at the bottom. Identify the location of the mean and the median by the letter. Okay, who's always at the tallest part? Mean or median? Median. When it is skewed, the median is always at the tallest part. So C is going to be your median. Okay, C is going to be your median. All right. And that means that your mean's a little bit farther down into the lower part. So my mean's going to be at A. Okay, so I just wanted you to have a visual for that. I think there is one in there where it asks you to pick which one's the mean and which one's the median. Median is always at the tallest point when it's skewed. Okay. All right, and for the last one, okay, I'm going to change the numbers in this because they're really kind of gross. All right, so if you'll flip that page over, there's one more example I want us to do because the one thing we've not done is draw a normal curve. All right, we drew the rectangle. We did a lot with uniform, but let's talk a second about this, okay? I'm going to change these numbers, and if you look, there's a bunch of stuff in here. But here's the important words. Normal distribution. When you see that, you're going to create that bell curve. That's what we're going to do, okay? So when you see the word normal distribution, that's what we're going to create. The mean is always going to go in the middle, all right? And they're going to use that letter. It kind of looks like a fancy M or a U, okay? We're going to change that number just to make it simple to 2.5, okay? Just for fun, because I want simple numbers. So my mean is always going to go in the middle, okay? And then we're going to change. Notice they did the little sideways 9. It's hard to see, sigma. But it also says standard deviation in front of it, okay? We're going to change that to 0.5, okay? So sigma is 0.5, right? And here's how we set up the curve. If I go forward 1, 2, 3 times, okay? I'm going forward a standard deviation. If I go forward, do you think we add or subtract? We're going to add, okay? So I'm going to add 0.5 each time. All right, so 2.5 plus 0.5 would give me a 3, plus a 0.5 would give me a 3.5, plus a 0.5 would give me a 4. Okay, so you're just adding forward for those 3 numbers, right? To go the other way, we're going to do it 3 times the other way. If I'm going to go to the left, what do you think I'm going to do? Subtract 0.5, okay? And that's all we really need to be able to do with the normal curve today. All right, is get the numbers that go on the bottom. So 2.5 minus 0.5 would leave you with 2, then 1.5, then 1. So we're just subtracting a 0.5 every time. Okay, so I think there's just one like that. The other 3 are uniform curves. All right, questions? Ready to work. Let's get her done. I think there's 4 questions today. Okay. So it's on Achieve if you need a computer. There's a few more up here. I tried to pick ones that would connect to the internet today and that are charged. I didn't do that yesterday. Okay, so should be able to get this done real quick. All right, is it 4 questions? Anybody in? Five, I lied. The last one's the normal curve though.